So we have around 15 people here. Can you hear me? You can write in the chat box also if you have any issues. Can you hear me?
No issues, ma'am. Yes, ma'am.
Okay, and can you see the screen? Is the screen visible to you?
Yes, ma'am.
Okay, great. Then let us start with the class because it's a very short class, and I will take the attendance at the end of the session. Okay. So in our previous classes, we have discussed about the relational model, and we had looked at the various concepts of the relational model, that is relation, relational schema, relation state. Then we had looked at the concepts of tuple, concepts of columns, domains, and so on. Now, in the relational model, there are also a number of constraints which we had earlier discussed. Okay, some more people are joining. All right. So, integrity constraints or constraints on the database is these are certain rules which are supposed to be maintained in any valid database state. So we have a database schema and then we have a database state. So the database state is nothing but the schema which is filled with data. So the constraints or the integrity constraints, as we call it, these are related to the rules that the data must follow when we enter it into the database. Okay. So we have already discussed three types of the integrity constraints, or ICS it is being called. So we have already discussed domain constraint, which says that every column for a tuple, the values that a column can take, it has to take an atomic value from the domain of that column. So if I have a column called SSN, and the domain of SSN is characters of length 9. Okay. In that case, for a particular tuple, the value that can be taken by SSN will be only 9-digit characters. Okay. So this is the domain constraint. Then the second is the key constraint. The key constraint, as again we have discussed earlier, that the key constraint states that no two tuples in a relation state will have the same value for the key. So two tuples, if I take any two tuples from a relation, then they will have different values for the key. Other values may be the same. And the third constraint we had looked at is the not null constraint. So the not null constraint specifies that if a particular attribute is specified with the not null constraint, then the value cannot be empty. The value for every tuple of that relation, that column should always have a value. So these are three constraints of the relational model. These are three types of integrity constraints: domain constraint, key constraint, and not null constraints. Now, in addition to this, we have two very important, or the most important constraints, integrity constraints in the relational model. These are called, first one is called entity integrity constraint. Entity integrity constraints. Do you have any questions? Any questions you have? Okay. All right. So this is called the entity integrity constraint, and the second one is called the referential integrity constraint. So let us see what are these different types of constraints. So first, let's see what is a entity integrity constraint. So the entity integrity constraint specifies that no primary key value can be null. Okay. So the key constraint says that two tuples cannot have the same value for the primary key. And the entity integrity constraint says that no primary key value will be null. So if I have a tuple T1 in my relation, and let's say primary key is denoted by PK, okay, primary key is denoted by PK, then for tuple T1, this cannot be null. It cannot be empty. Now, if you can relate this with the key constraint, so if I have two tuples, T1, this gives me the value of the primary key for this tuple T1, and I have another tuple. So the value of the primary key of this, it cannot be the same. This is the key constraint. And what we have here, the primary key of any tuple, it cannot be null. So this is the entity integrity constraint. So if you come to think of it, if I allow null values for the primary key, then it means that more than one tuple can have null. So I may have two tuples which has null value for the primary key. So in such a situation, my key constraint will be violated. That means two tuples. Suppose let us say for I have for tuple T1, the primary key is null. And for tuple T2 also, primary key is null. Since I'm allowing null values, so I can have two tuples which both have null for the primary key. So if I have this, then this condition is not satisfied. The key constraint is not satisfied. So in that case, PK cannot be the primary key. Okay. So in short, entity integrity constraint says that primary key can never be, the value of the primary key for any tuple cannot be null. So that is the entity integrity constraint. Let's look at the next constraint. That is the referential integrity constraint. So referential integrity constraint, it deals with your foreign key. All right. So yes, Vinay, some issue. Okay. So let us look at the referential integrity constraint. So referential integrity constraint, it deals with our concept of a foreign key. So foreign key, we have already seen that a foreign key is a key which exists in a different relation, okay, which is actually links it. It is the primary key of one relation and it appears in another relation as a foreign key, in the sense that two tuples of these relations will be related via the foreign key. So this referential integrity constraint deals with this. Okay, so it is the definition is given as it is specified between two relations and is used to maintain the consistency between tuples in the two relation. Okay, so it will, what does it state? It states that the referential integrity constraint states that a tuple in one relation that refers to another relation must refer to an existing tuple in that relation. Might seem very confusing, but let's say this with an example. Let me explain what it means. Okay. So let's read it again. The referential integrity constraint states that a tuple in one relation that refers to another relation must refer to an existing tuple in that relation. Okay. So let's see an example. This is the relation state that we have, okay, of our company database. So if you remember, employee is related to department. Okay, we had this employee relation. So all these attributes were there, F name, L name, and so on. and there was an attribute called DNO. Okay, and then we had the department relation. Department. So there we had D number, D name, and so on. So here in the employee relation, DNO was the foreign key. DNO was the foreign key. And here in the department relation, D number was the primary key. Okay. So since this was the foreign key, it referred to D number of department. Okay, in the schema. So by drawing this arrow, we can link the foreign key with the primary key. Now, look at the data. What does it say? What does the referential integrity constraint say again? It says that, again, if you see, a tuple in one relation that refers to another relation. So a tuple in one relation that refers to another relation. So here, employee refers to department relation. Okay, so let us pick any tuple from the employee relation. Let's look at this. Okay, so if you see, let's take this one, Jennifer, this tuple. Okay, so you can see Jennifer as well as, okay, this is her SSN, then her birth date, address, sex, salary, super SSN, and DNO. So from here, you can understand that DNO is 4. The DNO has the value 4. So this is a tuple which refers to department relation. Which department? Department number 4. So which one is department number 4? It means this one. Administration, because it has DNO, department number as 4. So this value here and this value here, this is the primary key. So the foreign key of employee, DNO of employee, refers to this tuple here. So again, if we look at the entity integrity constraint, the referential integrity constraint, it says that a tuple in one relation must refer to another, that refers to another relation, must refer to an existing tuple in that relation, must refer to an existing tuple in that relation. So if you look at this 4, this tuple refers to 4. So 4 is already existing in department. So this is valid. Let us look at each of these in the department. I have DNO. This is DNO here is 5. For this one, DNO is 5. Is 5 existing? Is 5 an existing relation in, is there a tuple with DNO 5, department number 5? Yes, we have research. Similarly, for the next one here, this is also 5. So yes, it refers to an existing relation. Next one is 4. So again, this also an existing one. Next one is 5. Okay. Yes, another one for research. Next one is also 5. So another one for research. Then next is 4. This is for administration. And then here I have 1, which is headquarters. Okay. So whenever I have a foreign key, which is referring to a primary key of another relation, the value of that foreign key must come from the existing set of primary keys of the other relations. So it must refer to an existing tuple in the referred relation. So employee is the referring relation and department is the reference relation. So it must relate to a existing tuple. So if suppose, let's say for example, just a second. Okay, all this has been removed. So here, let us say that instead of 5 here, let's say the value here was 7. Okay, the department number was 7. Now, if I try to find a matching tuple here in department, I will not be able to find because there is no tuple in department or with department number 7. Okay, so if I have a value like this, then this is said to violate the referential integrity constraint. So this violates the referential integrity constraint. So the referential integrity constraint, again, let me repeat, it specifies that if a particular tuple in a relation refers to another tuple in a different relation, okay, then it must refer to an existing tuple. So here, existing tuples for department is with department number 5, 4, and 1. These three. Okay. So any values that appears here will be only for 5, 4, and 3. It cannot be anything else. Okay. So that is your referential integrity constraint. Okay. You can see some more examples out here. If you look at, let's say super SSN, okay? SSN, super SSN. Let's look at super SSN. This is also a foreign key here, which refers to what? SSN of employee. Okay. So any SSN that appears in the foreign key super SSN must come from this set of values, must come from here. Okay. So like you can see 333 for the first tuple, 333. What is the value? 445555. So does it exist here? Yes, it exists. Okay. For the second one also you can see 88866. So does it exist? Yes. For the next one, 9876. So 9876. Where is it? This one. Well, yes. Same way, you can find that only the ones which are there will be, which are existing as the primary key will be allowed as a value for the foreign key. So this is because of your referential integrity constraint. You can check this for all other tables, all the other tables also, and you can see how this constraint will work. So any questions so far? You can type it in the chat box also. Any questions? You can look here also, department number in department locations table. You have department number, the D number, which is the foreign key. It is referring to department number here, this department number. So it must be the values here must come from the values that are existing here. So you can see all combinations of 5, 4, and 1. Okay, 5, 4, and 1 only. Similarly, project number, this is the primary key. And where does it appear? It appears here as foreign key. It appears in works on as foreign key. So the values for the foreign key will be taken only from this set of values. Okay, so this is your referential integrity constraint. So I can see 2 questions. Okay, there's one question from Meshwa to repeat. I didn't get it. Which part? Repeat which part? The referential integrity? If I give the definition again, so again, if you look at it, the referential integrity constraint states that a tuple in one relation that refers to another relation. So I must have one tuple in one relation which is referring to a tuple in another relation. It must refer to an existing tuple in that relation. So if X if a tuple in X is referring to a tuple in Y, it must refer to an existing tuple. So you can see In this case, department number is a foreign key in employee. It is referring to the number of department. So whenever I have a value for department DNO in the employee table, then it must come from, all these values must come from this particular set. It must refer to an existing tuple. So I cannot have a department number here called 8 because 8 does not exist here. It does not refer to the a tuple in the department relation. So that is your referential integrity constraint. And the formal definition for this, okay, you can see the formal definition of referential integrity constraints. We can write it like this. So we are considering two relational schemas, R1 and R2. So R1 is one relational schema and R2 is another relational schema. So in R1, let me try to write down here R1 and this is R2. So in R1 has a primary key. Okay. So a set of attributes Fk in relational schema R1. So here I have a set of attributes. It may be one single column or it may be multiple columns. So a set of, that's why it's called a set of attributes. A set of attributes Fk in relational schema R1 is a foreign key. So I have here, this one is my foreign key in R1 and it refers to which relation? It refers to relation R2. How does it refer to? So here I will have a primary key. This is called this is primary key 1 for relation 1 and this is primary key 2 for relation 2. So a set of attributes Fk in relation schema R1 is a foreign key of R1 that references relation R2 if it satisfies the following rules. So this is a foreign key which refers to this, okay, if it satisfies two conditions. What is the condition? The attributes in Fk have the same domain as the primary key attributes Pk of R2. So domain of, first condition, it says that domain of Fk in R1 should be the same as domain of Pk2. What is Pk2? Pk2 is the primary key of relation R2. What is Fk? Fk is the foreign key in R1 which refers to relation R2. Okay, so they must have the same domain. That's why when we did SQL, I mentioned that it should have the same data type. The same data type must be there. And what is the second rule? First is they must have the same domain, and the second is a value of Fk in a tuple T1. Okay, now we are talking about the relation state. So if there is a tuple T1, okay, T1 will be where? T1 is in R1. The value of Fk in tuple T1 of the current state R1 of R1, this is R small r1 of the relation schema R1, either occurs as a value of Pk for some tuple T2 in the current relation state R2 or is null. So that means the second conditions here says that if I have a tuple T1, what is T1? T1 is the tuple which belongs to a relation state R1 of the relation schema R1. And so if I have this, then the value of the foreign key for tuple T1 should be, okay, it should either occur as a value of some tuple T2. What is T2? T2 belongs to some relation state R2 of the relation schema R2. So T2, it must appear as one of the values of the tuple T2 of the primary key, or it can be, or this foreign key can be, so either this or it will be null, Okay, so these are the two conditions that it must hold. If both conditions hold, then we say that there is a referential integrity constraint from R1 to R2. Okay, so this is the formal definition. If we go back to our screen here and let's see how, let me give see this example, just what we explained here. So here I have dependent, or okay, let's take the super assistant, employee, super assistant. So so here, if you look at the super SSN attributes, then you will see that this is a foreign key. Okay. So if I say tuple T1 is the first tuple, this tuple is tuple T1. So for this tuple, the value of the foreign key, which is what? Which is 333445555. This is the value of the foreign key for tuple T1 must appear as a value of the primary key for another tuple. So here it is the reference relation and the referencing relation is the same. Both are employee. So I must find a tuple T2 with the same value as the primary key. So can I find? Okay. Yes. Which one is my T2 now? This one. This is my T2. If this is my T1, this is my T2, because this is for this tuple T2, the value of the primary key, which is SSN, is equal to what? 33445555. No, 333, three triple threes. 445555. So this is the same. So first, this condition is satisfied. And both of them, they have the same value. They have the same value. They have the same, sorry, they have the same domain. Okay. Super SSN and SSN, they have the same domains. So both our conditions are satisfied. So this means that the referential integrity constraint between super SSN and SSN, this one, it holds. All right. You can look at other values also, like here you can see MGR SSN. MGR SSN refers to what? It refers to SSN of employee. So if I say T1 is this one, this one is my T1, okay? Then I have to find a value T2. I have to find a tuple T2 in employee with the same value for this. So there I get this one is T2. For this one, for this tuple, if this is my T1, then what will be my T2? I have to find a tuple with SSN 888665555. So 888665555. This is my T2 in that case, because it has this. Okay. So this is your referential integrity. This is the referential integrity constraint. And this is the formal definition of it. So what is a referential integrity constraint? So you have to give this as the formal definition. Okay. So this is about the two constraints that we have. That is, first of all, we have the integrity constraints called domain constraint. Domain. What are the various constraints? Domain constraints. Then I have key constraint. Key constraint is two values of the primary key of a relation cannot be the same. Then we have the not null constraint. Then we have entity integrity. And we have the referential integrity. So these are the various integrity constraints that are there in the model, in the relational model. And I have already explained that you can connect, you can diagrammatically represent the foreign key and the primary key. You can connect them, like here DNO is connected to D number here. So you have to draw an arrow to represent this referential integrity. So that is all for the class today. Okay. Now, to implement this,